Today, let's see graphs and an algorithm on graph. So, firstly, let's understand what is a Hamiltonian cycle. The definition is pretty simple, right? Hamiltonian cycle means it is a cycle in a graph that visits each vertex of graph exactly once. Hamiltonian cycle. How do we define it? It's a cycle in a graph that visits each vertex of graph exactly once and returns to the starting vertex. This is more important. मतलब a complete cycle, जहाँ से शुरू किया वहीं पे खत्म भी होना चाहिए और सारे वर्टेक्स विजिट भी होने चाहिए. Starting point should be equal to your end point and you should have visited all the vertices that are present in the graph. Is the definition clear? This is known as Hamiltonian cycle, right? So basically, if you see here, do we have a Hamiltonian cycle? Let's say we start from 0, we move to 1, right? Then we move to 2, then 4, then 3, and then again 0. Right? I could say this is a Hamiltonian cycle, right? So we do have a Hamiltonian cycle. Here do we have a Hamiltonian cycle? It's not possible, right? Let's say I start from 0, 1, 2, 4. I come back to 1, right? Then I come back to 3, then I come back to 0. So उसमें क्या हो जाएगा? 1 will be repeated twice, right? But what did I say? Each vertex of graph exactly once. That is more important. Here there is a cycle possible. 0, 1, 2, 4, 1, 3, 0. All vertices are covered, but one is repeated. Hamiltonian cycle, every vertex only once. Very clear, right? So if I ask you to find Hamiltonian cycle in a graph, what's a brute force way? You try out all the possibilities. Total कितने possibilities बनेंगे? Let's say n vertices I have. N vertices. So you could start with any of the n vertices. Then you could move to any of the n minus 1, n minus 2, so on. Last में एक ही बचेगा. तो total n factorial. Yes or no? This is trying out all the possibilities. That 0, 4, 2, 1, 3, 0. That is one of the possibilities. And then check कि 0 और 4 के बीच में तो ऐसे exist नहीं करता. Then you discard that possibility and move on to the next. This is a brute force. Yes or no? Is a brute force clear? The time complexity would be n factorial. Alright. Now let us try to see the solution of this. Let us try to see the solution of this using backtracking. See, now the best part about Hamiltonian cycle is, since it's a complete cycle, start और end point same है, तो आप किसी भी point से start कर सकते हो. My point is, if this is a cycle 0, 1, 2, 4, 3, 0, right? 0, 1, 2, 4, 3, 0. I could start from 0 and end at 0, right? Yes. I could start from 0 and end at 0, but also I could start at 1 and end at 1. 1, 2, 4, 3, 0, 1. 1, 2, 4, 3, 0, 1. Right? 1, 2, 4, 3, 0, again 1. I could start from 2. Right? 2, 4, 3, 0, 1, 2. Are you getting it? Since it's a cycle, you could, and it starts and ends at the same vertex. All vertices are covered. Each vertex appears only once. So you could start from any vertex. So that's the best part. Let's say I start from 0. Right? Then let's say I move to, let's say 3. Okay? Then I move to, let's say 1. I'm just choosing, there are many possibilities, I'm choosing one of them. So 0, 3, 1, then I'm moving to 4 and then I'm moving to 2. right? Cycle complete नहीं हुआ. Then what I do? Backtrack. I go back to 1, right? So 0, 3, 1. Let's say I move to 2, and then I move to 4. Again, नहीं हुआ. So let's say I backtrack. I go to 0, 3, then I go to 4, then I go to 2, then I go to 1, and then I go to 0. I found my answer. Is backtracking clear? I start from 0. I try out every other vertex. If there is an edge in between, right? If there is an edge, I try out every other vertex, right? And just check if it's possible to reach, right? Let's code this, okay? And see, let's try to write a modular code for this, alright? As modular as possible. Okay, so firstly, what should my function return? A path, a cycle, right? A path. How would you represent it? Vector of int, right? Vector of int. Let's say the name of the function is Hamiltonian cycle. Input क्या होगा? ग्राफ को adjacency matrix में you can use. So let's say I input adjacency matrix. Let's say A, D, J, M, and T. Alright. This is the only thing that is required. या और कुछ input लगेगा. Adjacency matrix में सब कुछ आ जाएगा ना. All the vertices, their connections, their edges. सबसे पहले what should I do? Let's try to find out the size, the number of vertices. Number of vertices क्या हो गया? If n are the number of vertices, it would be what? The size of the matrix, right? Yes or no? Okay. And let's say vector in return करना मैं उसका नाम path दे देता हूँ. Path, P-A-T-H. तो vector int path. Alright, it consists. What would be the size of path? Can someone tell me? N होगा, क्योंकि Hamiltonian cycle में सारे vertices होते हैं, तो N ही होगा, right? And I am let's say initializing it with -1. Is this thing clear? Now backtracking में क्या करोगे? सबसे पहले path को initialize. That is what I was trying to tell you when I was trying to draw multiple Hamiltonian cycles. That you could start with any vertex, yes or no? So let's say I start with 0. So path of 0 is 0. What does this mean? 0 is my starting vertex. Now I need to visit all other n-1 vertices and reach back at 0. अगर मैं पहुंच पाया, then there's a valid Hamiltonian cycle. अगर नहीं पहुंच पाया, then there's no cycle, right? So let us try to write one more function here. Since this is our main function, we write a utility function, right? So if Hamiltonian cycle utility, alright, and I am passing adjacency matrix to it, right? What more I pass? I pass the path vector to it. उसी में तो मैं आंसर स्टोर करते जाऊंगा. Yes or no? Yes. Path. What more? Let's say you also pass the number of vertices, but there's one more thing in backtracking which you need to pass. What's that? Size को pass करना ही है. So let's say I also pass n. One more thing. कि अभी आप कौन से पोजीशन पे हो? Right. So let's say 0 is already done, and I am moving to 1. So I just try 1 next, and total vertices n. So if this doesn't exist, I can directly return -1. If this function now will try to calculate the Hamiltonian cycle, right? If it doesn't exist, I return -1. If it does exist, What will I do? I will return path. Is this thing clear? Very clear. Now let's try to write a given function. I'm doing it. Alright, can someone tell me how will this function look like? सबसे पहले let's write the function. Quickly tell me the parameters. What's the function name? What will this return? This will return a boolean value. Yes or no? Yes. So a boolean value. Hamiltonian cycle util, right? पहला क्या था? Adjacency matrix, so it's a vector of vector. Vector of vector. Adjacency matrix, second one is path, it's a vector in. Then you have an integer called as position, right? And then let's say you have int n, right? Is this thing fine? Backtracking में सबसे पहले क्या चेक करोगे? If you have reached the base condition, कैसे पता चलेगा कि सारे edges cover हो गए? अगर ये जो position आपने जो अभी point pass करी है, if that is n, right? तो I can directly say if position equal to n. Right? That means all the vertices are covered. I have reached the last vertex, but last vertex पहुंचने के बाद I need to reach again the starting point. So what I check whether an edge exists between what last and first. So I can directly write here return if the edge exists, it will return 1. If edge doesn't exist, it will return 0. True or false? Edge adjacency matrix में, right? किसके बीच? पाथ ऑफ 0 और किसके बीच? पोजीशन का वैल्यू अभी n है. पाथ का साइज क्या आएगा? Size of path is what? n. So last index क्या होगा? n minus 1, right? So adjacency matrix of path of n minus 1 and path of 0, right? जहाँ पे ऐड किया वहीं से स्टार्ट भी करना होगा, तो स्टार्ट 0 से किया तो there should exist an edge between your last जो भी vertex है that and first, which is path of 0. Is this thing clear? Yes. All right. Okay. Now how will you backtrack? Backtrack में क्या करोगे? जैसे हमेशा करते हैं, you will try out all the possibilities. How many possibilities are there? 1 से लेकर हाँ 1 से लेकर n-1 possibilities, right? क्योंकि path of 0 में 0 तो you have already added. So I will directly write here for integer next to vertex b starting from 1 less than equal to n. Let's say I'll just write less than n. So until n-1 b plus plus, right? Okay. Now tell me what all things you do in backtrack. सबसे पहले तो जिस पोजीशन पे आप ट्राई कर रहे हो उस पोजीशन पे you will try out that vertex, right? But there are 2 or 3 more conditions उसी केस में you can try. First, edge exist करना चाहिए और दूसरा हाँ Exactly, it shouldn't be visited because you could visit every vertex only one time, right? So let us say v equal to 1 से हम तक तो try कर ही रहे हैं, right? So two different condition check we have to do, right? So just for the sake of modularity, let's write even उसका ये we will write a function for that as well. Just two conditions we have to check. What are the two conditions? There should exist an edge between जिस भी पोजीशन पे आप ट्राई कर रहे हो वर्टेक्स V, right? And वो रिपीट नहीं होना चाहिए, right? So both the things will check if the function let's say is safe. क्या क्या चीजें पास करोगे इससे में? Obviously adjacency matrix, path, position, and this vertex V ना V के लिए you are checking, right? If this is done, then I can directly write path of position equal to V, because now vertex V is safe. आप V ऐड कर सकते हो आपके पाथ में. Now what you do? बैकट्रैक करना है ना, तो भी वापस सेम फंक्शन कॉल करोगे. Backtracking is that now you have moved on to the next position. Now you repeat all the things again. So it's or no?
Yes.
NP पे बुला करते हो. Next के बाद वापस you have to repeat it और same process again and again. So now if this is safe, I equal this function again. Hamiltonian cycle utility. Let's say utility. First क्या है? Adjacency matrix. Second path. Position अभी +1. Is this clear? Yes or no?
Yes, sir.
Now what you do? What will this function return? True or false? Right? So obviously I pass this in. If what if it returns true? If this returns true, मतलब you have a path, so you can directly return what? True to the main function, na? That you have a path. So I directly return true. Right? What else? Abhi you have to backtrack. मतलब you tried vertex V at the position QS, it didn't work out. If it would have worked out, you would have returned true. Now since it didn't work out, what will you do? Path of position equal to initial value क्या छोड़ता था? -1, right? Here initialize it with -1. Path of position equal to -1, and your for loop is over. Now अगर ये इतना सब करके भी मतलब you tried out all the possibilities and you didn't get an answer, so finally what you will do? Right? Let's write the same function, just two conditions check, right? कहाँ पे लिखा है? इस सेफ का फर्स्ट क्या पैरामीटर? इस सेफ will also return what? Guys, everyone is with me, I hope, right? Right? So इस सेफ का true or false, so it's a Boolean function is safe. What's the first thing? Adjacency matrix से होगा vector of any adjacency matrix, then path, then position, right, and then which vertex you are trying it out for, yes or no?
Yes, sir.
Last function here I will just bear with me. Which vertex you are trying it out for? So I'll just write in. सबसे पहले what should I check? Whether an edge exists or no. Between what? Position minus 1. Yes or no? Position पे t स्टोर करा आपने, तो इसके पहले वाले पोजीशन पे जो एक वर्टेक्स था, between the previous vertex and the current vertex. Current vertex is v and previous is path में position minus 1 में whatever it was. So if let's say if there doesn't exist an edge, if there doesn't exist an edge between position minus 1 and vertex, yes or no?
Yes.
If there doesn't exist an edge between position minus 1 and vertex, you could directly return false. Now suppose there exists an edge. One more check we have to do. That is, if this vertex that we are trying doesn't already exist in path, right? So what can I do for int I equal to 0, I less than position, right? Are you getting what I'm trying to say? I just want to check that the vertex that I'm trying out for, that vertex shouldn't exist in my path. तो path के कौन से पोजीशन पे हुआ? POS पे, तो 0 से लेकर POS minus 1 तक I check all the मतलब array elements and एक भी जगह vertex नहीं आना चाहिए, yes or no?
Yes.
Right? So for int I equal to 0, I less than position I plus plus, right? If path of I is equal to what? Vertex. If path of I equal to vertex, repeat हो रहा है, I will do what? Return. And अगर repeat नहीं हो रहा है, everything. Two conditions I told you we have to check. यहाँ पे भी it is true, यहाँ पे भी it is true, तो finally what will we do? This is how you code, right? You understand the algorithm first, right? You try to be as modular as possible, right? Anywhere you find that more than 5-6 line का code हो रहा है and that code is being used again and again, don't get into complexities. Directly convert it into a function. Why? Because since I have so many functions here, is safe and something. If it's a very big code, function का जो return value है वो print करके देखो, तो at least you could identify whether that function is working fine or not. If that function is working fine, you know that the bug doesn't lie in that function, it lies someplace else. Then other function also you could test the same way, right? Is this thing very clear? Backtracking is very clear. Backtracking is basically what you try out all the possibilities. Right? You try the possibility, you reach a dead end, you backtrack, try the other possibility, dead end, backtrack, other one, backtrack, यहाँ पे सारे possibilities खत्म हो गए, backtrack, यहाँ के भी सारे खत्म हो गए, backtrack, and now some other one. And as soon as you reach a proper destination, you are done. Right? That is what we are doing. Right? Is safe, return false, return true. Right? We have started from path of 0 equal to 0. Right? Then we are assuming one pass कर दिया, right? Hamiltonian cycle utility function. यहाँ पे what are we doing? We are trying out all different vertices. If it works out, fine. We'll try out the next one and the next one. जहाँ पे वर्कआउट नहीं किया दिस विल रिटर्न फॉल्स, राइट. एंड इफ पोजीशन इज इक्वल टू n and there exists an edge between last, that is path of n minus 1, last edge to the starting edge, then you return true, वो यहाँ पे चले जाएगा. If it returns true, I return the path. If it doesn't return true, I return minus 1. Very clear?